So you've followed this tutorial series. You've implemented an audio plugin with WebViews using JUCE 8. How to distribute it to your customers? That's the topic of this video. Hi everyone, my name is Wilczek and I'm the founder of the WebView2 blog and YouTube channel on audio programming. In this tutorial series, we explored how to create an audio plugin that runs in a digital audio workstation and has a web-based UI, a UI built using web technologies like HTML, CSS, and JavaScript, but also React, Vue, Svelte, etc. The integration of web technologies for building the UIs of C++ plugins is possible thanks to WebViews, hosting web content in a native application. Let's start by revisiting how plugin distribution without WebViews works on a high level. When you want to share the plugin you made with the world, you need to package it for distribution. Traditionally, this means creating an installer or simply shipping the plugin binary to your customers. An installer is an executable file that contains the plugin binary in the desired format and any additional assets and files the plugin needs to run correctly. The plugin binary is in one of the plugin formats, for example, VST3, AU, or AAX. The additional files may contain presets or dynamically linked libraries, DLLs. With WebViews, the matter is more complicated. There are two main points you need to take into account when distributing a plugin with WebViews. First, you need to ensure that prerequisites necessary for your WebView to work are installed on client machines, the machines your customers use to run your plugins. Depending on the operating system you target, you may need to take extra steps to create a proper environment for the WebView to work. This may mean that you have to include a WebView runtime installer with your plugin installer. Second, you need to decide how to distribute the web UI files with your plugin. They may be handled as additional assets, but may also be embedded directly in the plugin binary. We'll cover both these points in this tutorial. Before we begin though, it is important to stress that this tutorial is about the difference between shipping your plugin with WebViews and shipping your plugin without WebViews. It is not about code signing or notarization, nor is it about creating an installer. Its goal is to show you what changes for you in distribution if you decide to introduce WebViews into your plugin. Feel free to use the chapters of this video to skip to the part that's relevant to you. First, let's discuss ensuring proper runtime on client machines. What is a WebView runtime? WebView runtime is a specific service running on your operating system that enables using WebViews in applications running on that operating system. The runtime may be shared by more than one app that is using WebViews. Let's say your customer launches your plugin using WebViews. The plugin will use some runtime to correctly display the UI. At the same time, there may be a separate plugin that also happens to use WebViews and uses the same runtime as your plugin. At the same time, the user probably has more apps open. Some use WebViews and the same runtime as your plugin. Others use WebViews and a different runtime, while yet other apps don't use WebViews at all and thus don't need a WebView runtime. In most of the cases, you have little or nothing to worry about when it comes to handling WebView runtimes. There may be cases, however, when you need to pay special attention to it. Let's take a look what are the runtime prerequisites on various operating systems. The matter seems most complicated on Windows. There you have to install WebView2 Runtime on client machines if it's not installed already and link to the WebView2 loader either statically or dynamically. How to bundle the WebView2 runtime is outside the scope of this tutorial, mainly because the matter is exhaustively treated in Microsoft's documentation. Here you can see the link where this documentation currently resides. I will also put it in the description. Once you decide on how to bundle the WebView2 runtime installer, you need to link to the WebView2 loader library. There are two types of linking to choose: static or dynamic. Static linking embeds the loader library into your plugin binary. Dynamic linking requires putting the loader library DLL file into a folder on the user's computer where the plugin can find it. Static linking enlarges the final binary, but is most simple in distribution, which is why it is probably the preferred approach. If, however, you're distributing a bundle of plugins that all need the WebView2 loader library, you should consider linking dynamically to reduce the overall size of the bundle. If you decide to link statically, you must define the JUCE use win WebView2 with static linking compile definition for the plugin project. That's the approach we've taken with the tutorial project. You can check it out in the project's repository on GitHub. The link is also in the description. If you decide to link dynamically, you should only define JUCE use win WebView2 flag and optionally pass the location of the DLL to web browser components constructor using web browser component options win WebView2 with DLL location. To summarize, when you distribute a plugin with WebViews for Windows users, your plugin binary needs to have the WebView2 loader library linked statically or dynamically. Static linking embeds the library into the plugin binary. Dynamic linking requires you to distribute the library as a DLL as an additional asset. In both cases, you need to bundle a WebView2 Runtime installer with your plugin installer and invoke it during installation. Okay, these were the runtime considerations for Windows users of your plugin. On macOS and iOS, JUCE uses WK-WebView from the WebKit framework to render the WebView. The framework comes installed on macOS 10.10 and later, as well as iOS 8 and later. Since JUCE requires your plugins to target macOS 10.11 or later and iOS 12 or later, the appropriate WebKit runtime is already installed on target devices. On Linux, your customers have to install the libwebkit2 GTK 4.1 package. If it's not available for their OS version, they should try libwebkit2 GTK 4.0 package. Compiled JUCE applications use whichever library is available at runtime. On Android, JUCE uses android.webkit library to handle WebViews. The WebKit library supports Android 5.0 and later. Since this is also the minimum deployment target for JUCE apps, you don't have to install any runtime on user devices. These were the runtime considerations on target devices if you're shipping a plugin with WebViews. Now, let's deal with the other important issue: distributing WebView files with the plugin. By this, I mean how we should serve the HTML, CSS, and JavaScript files so that the user can see the web UI as we developed it. The WebView embedded in your plugin's UI needs files to display its content. It can either take these files from an arbitrary address from the web, a local development server, or a resource provider registered in the C++ code of the plugin. In our tutorial, we used a local development server to quickly iterate on our plugin's UI. This is not an option for your end users. You cannot force them to run a server on their computer just to run your plugin. You also don't want the WebView to show content from an arbitrary server on the internet, which would prevent the offline use of your plugin. This leaves us with just one option to serve your web UI files. You need to return them in your C++ implementation of web browser components resource provider. If you think about it, WebView files are no different from any other files you might ship with your app, like images, samples, or presets. This leaves us with the following options to package them. You can put the files into the installer and install them alongside the plugin in an installation directory. However, this is risky because they may get modified by the user. You can use JUCE's binary data toolset and embed the files directly into the binary. In this way, there is just a single binary file to distribute. In both cases, You can put your resources in a possibly compressed archive file with a layer of protection. That requires writing a little bit of custom unzipping code, but makes it very simple to add new files to the binary. It's up to you to choose a method that works for you. Personally, I would zip the resources and bundle them as a JUCE binary data asset with my plugin, and this is the approach that I'd like to show you in the last part of this video. Okay, we are back in our tutorial project, and don't forget that the full source code is available on GitHub and it gets updated so that you can always reference it back and forth. So we want to package our web UI files as binary data. So let's try the naive approach, just bundling HTML, CSS, JavaScript files as binary data. So normally how we do it in JUCE, then we go to CMake list.txt for our project. Let me close the console window. And let's see, you have this JUCE add plugin at the top. And then we add stuff to this target. So actually, to have binary data, we need to create yet another target. And the command to do this is called JUCE add binary data. And we'll call this WebView files. And here we need to pass the name of the header where our binary data will be accessed. So we must call header name argument, and then we pass webviewfiles.h. This will be a header. And then we need to pass the namespace in which our binary data will be accessible. And this is good practice to do this because otherwise we'll get simply a default. So let's go namespace WebView files. And then we need to specify the sources that we want to package as binary data. So we go sources. And now let me see. We have our UI public folder, and then we have index.html, then we have index.js, and we need to bundle all these. So let me define a helper variable. I'll name this WebView files source directory, and this will be simply CMake current source directory. This is a special CMake variable, and then we go UI and public. So now it should be quite easy to specify our sources. So let me list them here. We'll go WebView files source dir, and we go index.html, and then we go WebView files source dir JS index.js. And remember, we need to include all files, so we need to go one layer down. It's JUCE index.js and JUCE check native interop.js. Okay, and now we need to link to this binary data. So when we have target link libraries and we have our plugin project, we can specify here in the private section WebView files. Okay, so now let's generate our project. So we go cmake-s.-b build. This will generate the project into the build folder. Okay, and now we can build the project, cmake-build. This will generate the binary data bindings, etc. Yeah, you could see it right here. Okay, our project built. So now if we go to the build folder and now to the plugin folder, and now here in JUCE binary data, we see that we have our binary files, and it actually contains the contents, for example, here on our index.html. And now if we open the webviewfiles.h, the file that we need to include in order to make use of the binary data, what we'll see is that we have here files index.js and index.js2. Okay, and now let's see how is this defined. So you see here we have named resource list, and it says index.js, index.js2. And here we have original file names. It says index.js, index.js. So which one is the right one? So we have one from JUCE, right? And one that is ours. And index.js is a name that you will encounter often. Not to mention that when we have a WebView and it requests js/juice/index.js, in this binary data, we have no way of differentiating which one we should return. So I found out that this approach is not the easiest one, especially if the list of your files gets longer and longer. Maybe if you're using some web framework that only generates, one CSS file, one HTML file, and one JS file, then maybe it's a feasible approach for you. But for the sake of this tutorial and the approach that seems more broadly applicable, we will first zip all the resources and we'll have just one binary data file, the zip file, and we'll read the files that the WebView requests from us in the resource provider from the zip file, and we'll return it. So that's what we'll do now. Okay, back in our plugin /CMake list.txt file, which as you can see is exactly right here, we want to zip our files first. So for this, we can use the file command from CMake. We'll go file, archive, create, and then output. And here we need to specify the output path. So for this, I would use CMake binary directory, and we'll specify the name, which will be WebView files zip. And now why the binary directory? Because we don't want WebView files zip clutter our source files, right? We don't want it to be seen by the version control systems, etc. And probably want to generate it often if the WebView files change. So that's why we put it into the binary directory, which makes sense because it is the output of our build. Okay, so now once we provided the name of the output, we need to specify the path. And here what I found that it's really helpful to specify, the absolute path to the directory that we have. So we can of course specify, CMake current source dir, what we had here, right? WebView files source dir as this one, but it's maybe problematic when the CMake is called from different folders, and then this file command may get simply lost. So the workaround that I found is simply we can go get file name component, and we specify, public path, so the path to the public folder. Maybe that's not the best name, but you get the point. And then here we can have WebView files source directory, and this will provide us with the absolute path to this folder. Okay, so here as the path, we can now go with public path. Okay, and now we need to specify the format, which will be zip. And what I also like to do, I like to make this command verbose so that we get, indication of what is being zipped. And now when we have this binary data, we don't need this stuff anymore. So we actually need this thing, right? So let me maybe create a new variable. So this will be set target WebView files zip path. Okay, let me set it here. And let me specify the sources here. Okay, and let's add this to the output right here. So now, because we changed the CMake list.txt file, we need to regenerate the project. This should zip our web UI files, and then we need to build the project, and this will build the binary data and link to our executable, and then we'll be able to see if it succeeded and if this approach is feasible. So to generate the project, again, I go cmake-s.b build. Okay, the argument should be paths, not path. Okay, and here you can get the list of the files that were zipped that is really awesome. And the build files have been generating. So now let me build it. CMake --build. Okay, the project built. So let me inspect what was actually built. So go to plugin, JUCE binary data and WebView files, WebView_files.h. Okay, and we actually have just a single file, which is WebView files zip. And in our C++ code, we'll read this file and we'll return the singular assets from it. And that's what we'll do now. Okay, in our plugin editor, we now want to prepare our plugin for distribution. So we don't want to go to URL local dev address, right? Because we don't want the user to have to start a local development server on their computer. So what we want to do is we want to go WebView, go to URL, get resource provider root, which means that whenever the WebView requests any file, our resource provider here will be called. And if we look here, this is our function where we return resources. So here you see that we are also using the resource file root. This unfortunately now has to go because we don't want to return files from the file system. We want to return files from our zip file. So the code that we have here, I think it can stay, but we need to change this to a different function. So let me call this get WebView file as bytes, because this will be a vector of bytes. And here we pass resource to retrieve. Let me put it on a single line. Okay, and now we need to have a different check here. So we'll go if resource not empty. Right, so we returned some bytes actually. So now we can return this vector, and so we don't need this anymore. We can just go stud move resource, and that will be it. But of course, we need to implement this function. And this is nothing more than an anonymous function that we'll define here at the top of the plugin editor file. So here in the anonymous namespace, go stud vector stud byte, and we have this function get WebView files as bytes, and we get this resource to retrieve as const JUCE string resource to retrieve. Okay, so this is a path that comes from our WebView as a request to a specific file that is, on a form like index.html or js/index.js, etc. So this contains kind of the full path that we have available. And in our zip file that's contained in our binary data, we have exactly the same information on the paths. So we have binary data that contains a zip file, which means we need to first read the binary data somehow programmatically, and then we need to go through the zip file and read the right resource. So in order to read binary data in full, we can use memory input stream. So we go JUCE memory input stream, and we'll call this ZipStream. And here we access the header that we saw before. So we go WebView files, that's the namespace that we use, and we go WebView files zip. And here, let me see if this works. Okay, it sees it here. So in order to use this header, right, to these declarations, I need to include the header. So I'll go WebView files.h. Okay, and now this should be available to me. Okay, so this is the beginning of the binary data file. This is a pointer to the bytes that represent this WebView files zip. And now we need to pass in the size, which is WebView files WebView files zip size. Okay, and the last argument to memory input stream is keep internal copy of data, which means whether the memory input stream should copy the bytes to its internal representation. Because this binary data is something that lives as long as our executable, so our binary exists, we can pass in false because this data is not modified. We don't need to copy it in any way. Okay, so we read the ZipStream from the binary data, but now we need to handle the zip stuff, right? And for this, JUCE has another class which is called JUCE ZipFile, and we'll call this ZipFile, and we pass here ZipStream to the constructor. Okay, and now we cannot easily access, the files in the zip because we're not just dealing with file names in the zip, but we're dealing with paths, right? So in order to make sure that the path that the WebView requests is in the zip file, we cannot compare directly the path in the zip file to the path that we receive, because there may be some discrepancies, there may be an extra character, etc. And dealing with this is, in essence, a pain, right? So to simplify this, we just match the last part of the path, and if it matches perfectly, then we'll read this resource and return. So we go for const auto I of stud views iota. This will generate numbers from 0 to ZipFile get num entries. We'll do the following. We'll get the ZipEntry, ZipFile get entry, and if ZipEntry file name ends with resource to retrieve, then we create an input stream. So we go const stud unique pointer JUCE input stream entry stream. We go ZipFile create stream for our entry, and we pass here ZipEntry. Okay, so this creates an input stream that allows us to read this file, and now we can simply go return stream to vector, and we pass here this entry stream. Okay, and if we iterate over the entire loop, then we return empty, right? Because we haven't found this file, so we return no bytes. Okay, it's possible that this is not included, so I need to include the ranges header. And now let me again build this project. Okay, the project built, so let me run this. Okay, as you can see, our project works. And why do I say that it works? Because, well, I haven't started any development server, right? And yet I can see my WebView here in plain sight, which means that the index.html, index.js, as you can see here in the background, all the JUCE stuff has been correctly zipped, and then in my plugin editor read and returned. So let me close this and let me quickly recap again, how this works. So whenever we create our plugin editor, we have our web browser component, right? And we can tell it go to URL. And this component will display whatever's the content of this URL. So far, we have been using this local development server, which means that somewhere else, we started a server that was serving the request for static files. And in our JavaScript frontend, we could request that we want to specifically request, get a file from our C++ backend disregarding the local development server. And this has been possible thanks to specifying this allow origin in parameter here. Okay, so that was one story. And now if I say go to URL and I specify the C++ backend as the resource provider, then every request every request, whether specific to C++ or general static file request from the WebView, will be served or should be served by C++. So if I get a request for a specific function or just a static file, a path, a URL, right? This get resource is called. And if we look at the structure, what we first handle are specific files that we don't have statically, but we generate dynamically. And then finally, if nothing has been returned before, so these names don't match, then we look in our zipped web UI files, our static files. And we do this, we read these files to byte, and we do this using memory input stream from JUCE's binary data that we first zipped in CMake. We zipped the web UI files, and then we add the zip file as binary data. If it feels confusing in any way, then don't hesitate to check out the tutorial project on GitHub and try tweak things, try to change things. This should yield a better understanding. And of course, if you implement your project, you'll definitely run into issues, and that's the best way to learn this stuff. So once you have your web UI files packaged with your plugin and you're returning every static file upon request that should be available from the C++ backend, you're good to go for your plugin distribution from the code side. To recap, when distributing an audio plugin using WebViews, we need to ensure that the target device has the appropriate runtime, and then the web UI files are bundled with the plugin. If you follow JUCE's minimum deployment targets, runtime considerations require action only on Windows and Linux. On Windows, you should bundle the WebView2 Runtime installer with your plugin and link to the WebView2 loader library. On Linux, your users must install the libwebkit 2 GTK 4.1 package or its 4.0 version. When it comes to distributing WebView files with the plugin, treat them as any other asset that you would normally ship with your plugin. A good default approach is zipping all web UI files and embedding them as JUCE's binary data into the final binary. As I said, the tutorial project is on GitHub and it gets updated to reflect the latest changes to the JUCE API. The link is in the description. If you have any questions or comments, please put them in the comment sections on YouTube or in the dedicated JUCE forum thread that I linked to in the description. This concludes the tutorial series on WebViews, but it does not conclude JUCE tutorials. So please subscribe to this channel and the Wolfson channel and turn on notifications to be notified when new videos appear. Thanks for watching and take care.